Hello. Now we are going to discuss and start learning about Google architecture. What kind of architecture we'll see introduction to that. How Google manages its Google Cloud. So first of all, the most important tool is Google File System that was being invented by Larry Page and Sergey Brin, which was earlier named as a Big Files. It was this Google File System is an extension of Big Files. So what is Google File System? So Google File System is a scalable distributed file system, just like Hadoop distributed file system that we had seen. So it's earlier this Google file system was being invented, and thereafter an open source version which is named as Hadoop distributed file system came up. So for Hadoop, this Google file system is the forefather. You can say its originator means original work is Google file system. So what does it mean? It provides you large distributed file system that could help you do the data intensive applications. What are data intensive applications? Suppose you want to make a Google. So for making a Google like search engine, you want to read all the web pages available on the world, and then you put data somewhere in your server. How you can do it with the help of such file system, which could have integration of multiple computers in a lab. So you suppose you have 1,000 computers, and you had deployed Google file system or Hadoop distributed file system on those 1,000 computer. You installed it and as a middleware. Now you crawl the whole websites, web pages in the world, and then keep on storing the index on this file system, distributed file system. That's how Google search engine works. So it provides basically fault tolerant. How fault tolerant? What happens whenever there is a fault? So there are automatic debugging or troubleshooting algorithms that were written in this Google file system that triggers up. Means if some system is down, then the replication of that files been already been done before its failure or something, like there are three replicas. So whenever one replica is down, then automatically third replica is being created to another machine. Then it is highly aggregated and performance to the large number of clients. So that's how Google file system, Google search engine works, because it's so much integrated with different machine that it is highly good for performance to provide to the large number of clients. It is widely used within the Google company for the storage purpose, the storage platform. Then it is used for generation and processing of data used by Google services. How? It is basically providing you the processing power of such a large file system. So what is Linux? Linux is also a file system, operating system, and operating system has a feature of file system, like you store the file, retrieve the file. Similarly, distributed operating system or distributed file system also have facility of storing and maintaining files. So this is Google file system, and it would be working as a Google service. It is in the research and development phase, and it requires large data set. So it can manage large data set. So research and development is still going on over this Google file system in Google. So it is one of the largest cluster that is having hundreds of terabytes stored across the thousands of disks on over the thousands of machines. So Google has thousands of machine. In that thousands of machine, there are thousands of disks that are storing thousands of terabytes of data. then it is how it is working efficiently. It is concurrently accessing thousands of machines, and who are accessing them? These machines. These are concurrently accessed by thousands of hundreds of clients at a time. Then earlier, what is happened in starting, Surgeon Brain and Larry Page had invented this as a file, big file. Big files is the predecessor name of this Google file system. Then files are being in this Google file system or big file. Files are being divided into fixed size that are chunks, which is of 64 megabytes. What happens? There's a terabyte, 1 terabyte file. So processing a 1 terabyte file or storing a 1 terabyte file or moving from hard disk to RAM or cache, it's very difficult to move 1 terabyte file. But what they did l- already broken up that 1 terabyte file into different chunks of 64 megabytes. And now what happens? They had many 64 megabyte chunks, and these 64 megabyte chunks can easily move to RAM and easily move to cache. This is the fundamental innovation behind Google file system. It does not implemented in kernels of an operating system. So it does not require such a Linux kernel or anything, because it is having their own library systems, their own user packages. That's the power of Java. So Java is the technology behind this Google file system. They basically implemented it without any operating system. Means it works as an independent bare metal deployment type thing. So, and it uses libraries for doing all these things. Then next, you can also go and see these links. Google Research Archive, Wikipedia page is there. So in this, you will get the famous paper of Google file system. It was being invented by first author is some Indian is there, and this is one of the leading research, you can say. And the first author name is Sanjay Gemawat. So Sanjay Gemawat is the first author of this paper, and this paper was being published in Symposium on Operating Systems Principles. And the abstract is about this Google file system, storage, and successful meeting out. And this paper was being published in 2003. So, which mentioned Google file system. Now we'll discuss about Google content management. What is Google content management? Basically, many users are there like OS, iOS, Android, desktop. So what they want efficient response from Google. How that Google manages? First of all, it the request goes to Google Load Balancer or Google Cloud DNS. So, what are Cloud DNS? Suppose you made a website over Google website. So, it you write some web pages over this Google website, and then you will have the working feature. And then what it does movement of Google website from one page to another page to another. So it basically resolves that which is the uh, web page link and website that you are searching. So that internal Google DNS is there, and IP addresses are also being resolved in that way. So load balancer, what it does whenever it search for management, it balances and it arranges resources and shifts the load to the free servers. So it has in this example, it is saying zone A, zone B. So it shifts accordingly. Automatic scaling is being done, and content servers are there. Means content are being fetched and shown to the Google search as a search. And there are two type of storage: static content and dynamic content. In static content, cloud storage is there, and the static storage is being kept over there. But in dynamic content, you will have a SQL like query language that you can run, and you can fetch out some of the informations in a systematic format like relational tuples. So what Google Content Management does web information, marketing campaigning like AdSense are there in Google, social media management like Google Meet or Google Gmails like Google have social networking as well, Google Plus. Then you have personalized for individual users or group. So you can create a group of different users, or you can make your individual uh, Google account for personalized use. Then Google platform does components and service for creation of content management system. What is content management system? It basically stores your Gmail. Stores various type of drives that you have files in your drives. So that part is being handled by Google Cloud Platform. So it is just nomenclature, naming. And the in backend there's everything Google Cloud. So there is Google Content Management, Google Cloud Platform, then Google Load Balancer. So they have different purposes and different activities, and they are being named accordingly. So Google Load Balancer do management of traffic support routing within the Google, and it transfers the load to the free zones and which are highly available. Then Google DNS is one of the good D- known DNS within a company. So inside the company, they themselves had created a DNS that provide DNS that manages domain name. For example, if you create your own website, then it will have some information of your website link, and that is being stored in DNS, and then that is type of DNS they have. Then there's also whenever you upload some file and whenever you shares it. So this actually these type of things are being resolved with this. And then static content and have what static content stores cloud storage. Dynamic content is basically more active, and that is having SQL based implementation for fetching out. So static content means uploading and downloading simple thing. Dynamic content you can run a query and you can process some complicated tuples. So this is what we had discussed. iOS and Android is calling, any device is calling. So it may go to Google DNS or it may go to Google Load Balancer. It will be automatically managed by Google. And when Google Load Balancer sees a zone is having less traffic, then that zone will get more traffic, and it will help to get fetch out or store out some data in Google Cloud Storage. And if there is a dynamic query or something intelligent is required, then it will go to Cloud SQL or Dynamic Content Management. And next, how Hadoop is there for Google Cloud Platform. How Hadoop is being installed inside Google Cloud Platform. So basically, what happens? Infrastructure is there that is having map reduce over Hadoop. There is compute power, computation power is there. Cloud storage is there to store some input and output. There's map reduce is there for doing some sort of jobs. So whatever we had studied in Hadoop, map reduce and something like that, it is also available at Google Cloud Platform. So you can use and the power of Google servers for doing computation as well as storage. And Hadoop master is there one thing which actually has to do SDFS name node and map reduce job tracker. So job tracker and name node task is being handled by Hadoop master. It is simple nomenclature. Then there are various nodes in the cluster that actually runs the map function and reduce function as a task, and then the data node is having the actual data which is being broken into 64 megabytes file, and then MapReduce task tracker has to do management of these movements of various MapReduce. Then backing up the storage through Google Cloud Storage that is being connected for Hadoop. So Google Cloud Storage is being connected with Hadoop, and whenever they want to fetch and upload the data to the Hadoop, they can do it from uh, Cloud Storage. SDFS can be used also in the Google's cloud storage. So these are the things that is provided by Google in for Hadoop. So this is an example that client is asking for computational power, and Hadoop master will transfer it to the uh, compute engine, and that compute engine will do the map reduce task. Either it will fetch or input some i- data from cloud storage. So cloud connector is there for Hadoop, and cloud storage is there for output data is being sent again to the cloud storage. So cloud storage is used in case of Hadoop in Google architecture. Then we'll discuss about web application on Google App Engine. So what it does, Google App Engine is a platform as a service. We already know and discussed about it. What we do, we deploy a web application on this Google App Engine. What it does basically simple development you do at the your laptop with some Eclipse operating system, Eclipse based IDE or something like that. Then you simply develop some, and thereafter when you are developed with that application, you deploy that web application at local host, and you troubleshoot it, check it whether it is perfectly fine or not, and in the end you deploy it directly to Google App Engine. So Google App Engine provides you what? Auto scaling for computational power, as well as it will help you integrate with distributed feature of Google's like memory cache, like task queuing, data store. These are the technology of Google, and that creates your application as robust, quickly to use, and easy to be managed. Means whatever you are using infrastructure of Google. You are using coding language and technology of Google, and your application will be as good as any Google application that you can see in the like YouTube, like Google search engine, like Google Maps. You can make such an efficient website or Google application if you have that level of innovation. Then you can write. There are four different languages available: Java, Python, PHP, Go for deployment purpose. Then support it. Basically, Google App Engine supports multiple applications and versions, which supports alpha beta type of testing. Alpha testing means you test on your own laptop, then beta test when you deploy it, and provide it to the users directly. Then memory cache, mem cache is a technology of Google that having in-memory cache. In-memory cache means whatever it will process, it will be processed in RAM so that it will be faster. It will be processed in cache so that the processing would be faster. And it provides higher speed as compared to ordinary servers. So how? Because it stores and access information being stored in cache itself. And for example, for that you have small data you can store on cache, like authentication and account information is being stored in cache, and detailed video or some images you store in normal hard drive, and from that hard drive you fetch the video and images. But for some faster action like authentication, username, password, these are very small strings. Some account information like your name, like some basic information that of your account is being stored in cache. And what they say it in memory cache, they say it mem cache. Then task queuing is another feature of Google App Engine that actually provide mechanism to offload lower running tasks to the backend server. What does this do? Task queuing? It basically whenever there is a long running task means it is taking too much time. So what task you do? Task you do to the context switching means shifting that longer task with a shorter task in the backend, and it basically freeing the front end server to service new user request. So these are the two uh, activities being performed by task queuing. What second one means, it will free and make availability of front end server that could be useful for new user request. Then Google Load Balancer, as we discussed, it basically provide transparent load balancing to the application. What it does efficient load balancing, and it provides better management of traffic of a number of users hitting to your web application. Then Google DNS, Cloud DNS is also there. It manages DNS domain for the user. What it does, it if you create your own website on Google, then what it does, it basically creates your own domain with your uh, web ID, or even you will think Facebook account you have, or Google Plus account you have. It is having starting with that link, that HTTP link. It is being specifically assigned with your name or account ID, you can say. So account ID, name, or something abbreviation that you had used would be used for as it will be decided as your domain, and whatever content you store will be stored within that domain. That things are being resolved in Google Cloud DNS. This is the architecture that we had just discussed. Suppose iOS or Android and a desktop application are asking for Google Load Balancer. What it does management of front end, that it will have better new user request processing, and it will do what? It will transfer it to the app engine, which app engine is free, and what which zone that app engine is free, and it will do the auto scaling. And this app engine is basically front end, and that app engine can do, it will store some data in static content cloud storage, or it can fetch out some data from this cloud storage. Then it can do dynamic query allocation and processing with this cloud SQL or cloud data store. Then thereafter, this mem cache we had discussed, it do efficient processing by storing important information like authentication and account information in mem cache. Then various task queuing is there, means whichever is having higher priority will be executed first, and this app engine is being managed in this way. Then how this Google App application is being developed. So there is a Google Web Toolkit being provided by Google or Google App Engine. So you use this GWT and its API for developing your own web application, which is rich with content, design, front end similar to the Google websites or applications like Google YouTube, like Google Plus, like Google Gmailing system. So you can have such rich APIs. Then GWT is like a Swing Java framework. You just have to drag and drop, and developers can write web application without writing HTML code. So it's a drag and drop like thing as well. And you can also write you do not need to write JavaScript code. It will be also uh, helpful with some mouse clicks, and you just mention what happens with the right click of this button. And in that you have to write the business logic. Then GWT basically helps you do the development environment, provide you development environment, just like any web server like Apache Tomcat, a PHP server that you had made, JDBC websites, you had made JSP, JDBC, or this Python based, PHP based website. Similar to that, GWT also provides you development environment. How it is being developed? It is basically developed as a desktop application. So Google Web Toolkit is a kind of desktop application development environment, and in your own desktop, means laptop or any machine computer, you can install this GWT and you can start developing uh, Google Web application. Thereafter it helps you do the debugging. How you can do it will directly launch your website in your local host browser, and you can see that there is some problem in uh, and you want to do some changes. You can debug it and you can refactor it accordingly, and you can run unit test for the web client. So GWT provides so-called local host mode, that what we had discussed, hosted mode, that allow developer to debug the Java code. Whenever you had some error in the Java code, you can it will come out when you are running on your own browser, means local host, and you can have web mode deployment, and which execute GWT generated JavaScript. All the things would be in your local host will be same as with the Google App Engine. Then Google App Engine having sites like Google Docs is also being developed in Google GWT. Google AdSense is also being developed by in GWT. Google Wallet, you see, Google Google Pay is also being developed in GWT. So other websites famous like Google Moderator. So these are various GoGrid.com. These are being developed on Google Web Toolkit and deployed over Google App Engine. So you can see the gallery of what are the number of GWT based Google App Engine deployment on this gwtgallery.appspot.com. In next class, we will discuss Eucalyptus Cloud as the infrastructure as a service. Google this Eucalyptus architecture will see Ruby on Rails, another kind of platform as a service. And thanks for today's class. I hope any is no question related to Google App Engine, or you have any query, then you can ask. We will quit and meet in next class. Any doubt or any query? Okay, so we'll meet in the next class. Bye.